Have you ever wondered where the concept of computer science originated? In the grand tapestry of human history, the genesis of computer science threads back to a time when civilization itself was in its infancy. More than 5,000 years ago, in the cradle of ancient Mesopotamia, the first known tool for computation was born, the abacus. This simple yet ingenious device was mankind's first step towards the realm of computational thinking. It laid the groundwork for the concept of an external device assisting in complex calculations, a concept that would eventually blossom into what we know as computer science. As the centuries rolled on, the human quest for knowledge and innovation never ceased. The abacus evolved, and so did our understanding of mathematics and computation. In the 17th century, an era of mechanical marvels and revolutionary thinking, two significant inventions came to be. First, we had Blaise Pascal, a French mathematician and physicist who, in 1642, introduced the world to Pascal's calculator. This was a mechanical device that could perform addition and subtraction directly, and multiplication and division through repeated addition or subtraction. It was a leap forward in computational technology, an echo of the abacus, but with mechanical sophistication. Then came Gottfried Wilhelm Leibniz, a German polymath and philosopher. He took Pascal's invention and improved upon it by creating the stepped reckoner. This device, capable of multiplication, division, and even extracting square roots, was a testament to the ever-evolving nature of computational devices. These innovations of the 17th century laid the foundation for the future of computing. They were the stepping stones towards a world where machines would not only assist in calculations, but also store, process, and retrieve information. From an ancient counting tool to the mechanical calculators of the 17th century, the seeds of computer science were sown. As we journey forward, we'll see how these seeds germinated, sprouting into the modern computers that have become an integral part of our lives. So buckle up and get ready for a fascinating journey through the annals of computer science. So, when did the concept of modern computing really take root? Let's take a step back to the 19th century, an era marked by unprecedented technological innovation and intellectual curiosity. This was the time when the seeds of modern computing were sown and the foundations for our digital world were laid. One pioneer who played a pivotal role during this period was an English polymath named Charles Babbage. Babbage, often referred to as the father of the computer, conceived the idea of a sophisticated device he called the analytical engine. This engine, although never fully realized due to technological limitations of the era, was designed to carry out complex mathematical calculations using punch cards for input and output. The concept was revolutionary, a machine that could process information, setting the stage for the computers we know today. But what is a machine without a user? Enter Ada Lovelace, an English mathematician and writer, who collaborated with Babbage on the analytical engine. Lovelace saw beyond the mathematical applications of the device. She envisioned that it could be used to create anything that could be notated in symbols, such as music and art. Her notes on the engine include what is recognized as the first algorithm intended for processing by a machine, earning her the title of the world's first programmer. Now let's talk about a concept that's integral to computer science, Boolean algebra. Proposed by mathematician George Boole in the mid-19th century, Boolean algebra is a branch of algebra where the values of the variables are true or false, usually denoted as 1 or 0 respectively. It's the backbone of digital logic design, which in turn is a fundamental aspect of modern computer architecture. From Babbage's analytical engine to Lovelace's visionary algorithms and Boole's groundbreaking algebra, these 19th century innovations laid the groundwork for what we now know as modern computing. The 19th century set the stage for the birth of modern computing, with innovative minds paving the way. But when did computers become electronic, and how did this revolutionize the field? The 20th century marked a seismic shift in the world of computing as machines transitioned from mechanical to electronic. This change was not overnight, but rather a gradual progression, fueled by human ingenuity and technological advancements. Let's take a step back to the early 1940s. Nestled within the walls of Iowa State University, two visionaries, John Vincent Atanasoff and Clifford Berry, were meticulously crafting what would later be recognized as the world's first electronic computer. known as the Atanasoff-Berry computer, or simply the ABC. This machine was a testament to the dawn of a new era in computing. But the ABC was just the tip of the iceberg. Shortly thereafter, the world was introduced to the Electrical Numerical Integrator and Computer, or ENIAC for short. Hailed as the giant brain, this behemoth of a machine was capable of solving large numerical problems at an unprecedented speed, a feat that was nothing short of revolutionary at the time. Now let's fast forward to the mid-20th century. The introduction of transistors marked another significant milestone in the electronic age. These tiny semiconductor devices proved to be a game changer, replacing the bulky and energy-consuming vacuum tubes used in early computers. The transistor sparked a wave of miniaturization in computer design. Components became smaller, computers became more powerful, and most importantly, they became accessible. From room-sized machines that were exclusive to scientific and military institutions, computers started to shrink in size, paving the way for personal computers that we are so familiar with today. In the grand scheme of things, the electronic age was a period of rapid evolution. It was a time when computers shed their mechanical roots and embraced the world of electronics. This transformation didn't just change the hardware, it revolutionized the very essence of what a computer could be and what it could do. The 20th century saw a monumental shift as computers transitioned from mechanical to electronic, a change that would shape the future of computer science. So, how did we move from giant mainframes to the digital devices we use today? This question paves the way for our journey into the digital revolution, where we witness the evolution from colossal computing machines to the marvels of technology that fit into our pockets. The digital revolution began with the birth of programming languages. In the late 1950s and early 60s, languages like Fortran and COBOL emerged, providing a more user-friendly way to interact with computers. These were the cornerstone of the revolution, transforming cryptic binary code into a language more humans could understand and use. As we moved into the 70s, the era of personal computing dawned. Companies like Apple and Microsoft were born, and computers started to shrink in size while growing in power and accessibility. The once exclusive domain of academia and industry began to permeate everyday life. The personal computer was no longer a far-fetched dream, but a reality within reach. But what truly set the stage for the digital revolution was the introduction of the internet in the 80s. This interconnected network of computers allowed data to be transferred across vast distances, breaking down geographical boundaries and creating a truly global community. Then, in the early 90s, came the World Wide Web, the ubiquitous WWW we see today. It was a game changer, providing a graphical interface for the internet and making it accessible to the general public. Websites were born, and with them, a new era of information exchange and communication. The digital revolution didn't just transform computers, it revolutionized society. It shaped the way we learn, communicate, work, and entertain. It brought about a new age of information, where knowledge is at our fingertips and communication is instant. The digital revolution made technology an integral part of our lives. From the smartphones we carry in our pockets to the smart devices that automate our homes, the digital revolution has made the world a smaller, more connected place. The digital revolution transformed computers from exclusive tools of academia and industry to an integral part of everyday life. And this is just the beginning. Who knows what the future holds? Where is computer science headed in the future? Well, the crystal ball of technology is as complex as the algorithms that drive it, but we can certainly glimpse at what's on the horizon. One of the most significant trends in computer science today is artificial intelligence, the sophisticated offspring of human ingenuity and machine capability. AI is increasingly becoming a bedrock of our daily lives, weaving its intelligent threads into everything from our smartphones to our cars, and even our kitchen appliances. As AI continues to evolve, we can expect a future where our interactions with technology become more natural, seamless, and intuitive. Then there's quantum computing, a realm where the ordinary laws of physics take a back seat, and the extraordinary takes the wheel. Quantum computing has the potential to revolutionize everything from cryptography to climate modeling. It's like being handed a brand new set of tools, with possibilities we're only just beginning to grasp. It could solve problems that are currently beyond our reach, opening doors to a future that's as exciting as it is unpredictable. And let's not forget blockchain technology, the digital ledger that brought us cryptocurrencies like Bitcoin. But its potential extends far beyond digital currency. Blockchain could redefine the way we handle data, offering unprecedented levels of security and transparency. It could change the way we do business, vote, and even how we establish digital identities. These trends are just the tip of the iceberg. The future of computer science could also see advancements in fields like bioinformatics, where computer science merges with biology to unravel the mysteries of life, or the development of more sustainable technologies to combat climate change. The future of computer science is as exciting as its history, promising innovations that will continue to transform our world. So as we stand on the brink of this digital frontier, let's brace ourselves for a journey of discovery, where each new innovation brings us one step closer to a future that's as limitless as our imagination.